neglecting air resistance, find A, the horizontal distance from the gun to the point where the projectile strikes the ground, meaning ang gilayon horizontally X, nasa figure X. Ang B, the greatest elevation above the ground reached by the projectile. So duha ka buok, no? Ang y max above the ground and the X, no? So if I'm going to put if I'm going to make this one as my axis, no? Usually I use this as my axis. Actually, the choice of an axis will depend on the one that solves the problem. So let's say we'll choose this one, no? I will put a shape here. Yeah, this one. This could be my x-axis. Okay, X. I will change color that one. How to change color? How to change color? Color. Format object. Color. Yeah, this one. I'm gonna choose that red. Yeah, ang size niya, tapan ako. Ito siguro. One. That's my X. And then my Y, I will copy that and then paste. So that's my Y. Okay. So in such a way that my initial value here is this is 0, 150, no? 0, 150. Meaning the X is 0 and then the height is 150, positive 150. Okay. Now the answer of your when the projectile hit the ground is when Y equals to 0. Okay. So there will be separate equation vertical and separate equation horizontal. Okay. If you are taking the horizontal axis, if you are talking about the horizontal equation, doon kay X as the change of position of the projectile, no? As the projectile changes its position, ang X niya mo vary, niya ang speed ana niya dx dt sub, the derivative of X with respect to t. Ang iyang acceleration along X is wala acceleration, no? Wala. Kaya naman, wala may gravity nga along X. Wala mo sa siya acceleration ni, no? Wala. Okay? So, kung wala siya air resistance, meaning dili siya mo slow down horizontally. Okay? So, if I'm going to write the equation here, no? Isulat na to ang equation. I will insert equation. Okay. I will say along style text along X direction. Okay. Ang isa sad along Y direction. Along Y direction. Okay. So along X X sub ito si 1, no? X sub 0, no? X sub 0. X sub 0 is equal to 0. Okay? Nya ang dx dt dx dt is equal to dx. Okay, and initially, kung butang dx is equal to 180 cosine 180 cosine of 30 degrees, no? 30 degrees. 30 degrees. That is what we call the initial, no? Initial V. Okay. Now, actually, acceleration along x is 0. A with x is equal to 0. Okay, that means no horizontal axle. Okay, based on the given, we can see that x as a function of time from the previous equation of v, okay, is equals to 180 cosine 30 degrees time plus constant of integration. The constant of integration can be solved that at time equals to 0, x is equal to 0. So therefore, x is equal to 180 cosine 30 degrees. P. Okay, that's the x. Okay. So that's it. These are the equation that we can determine at 1. So okay, that's it. So along x-axis, okay. So along x-axis, mo na imong ma-conclude along x-axis. Along x direction, x sub o, if this is our 1, is 0. And then dx dt is the horizontal component of this 180, okay, which is 180 cosine of 30, okay, degrees. That's the initial v, okay. Now acceleration is 0 because not in the problem that acceleration along x is given, okay. So there's no given, so we can say that there is no acceleration along x, no. It's just a projectile, okay. So with the differential equation here, dx over dt equals to 180 cosine of 30 degrees, we can differentiate that, no? So we have x 180 cosine 30 degrees t plus c. But at times 0, x is also equals to 0. We have already that at the top. So our final equation for x is 180 cosine of 30 degrees. So we can make a graph out of that, no? But it's still premature to do that, no? So we will continue with the y, okay? We'll continue with the y. So palayon to sa y. Okay, so opposite along y direction. Okay, y direction. Okay. So here YO is you are already above the ground at initially, no? Initial Y is 150. This is 150. Okay. And then we know that there is acceleration. Acceleration is equals to negative 9.51. That is caused by the gravity. Okay. Acceleration is 9.81. And we know that the derivative dvdt dv dv subscribe na to na siya og y over dt is equals to acceleration na siya, no? A sub y in which, okay, ay na siya, in which that is equal to minus 9.51. Okay? Now, kung ato na siya i-differentiate, doon na tayo v subscript y is equal to minus 9.81 p plus the constant of integration. Okay? Constant of integration. Now, at time equals to 0, B1y is equals to 180 sine of 30 degrees. Sine of 30 degrees is 0.5. So, you will have, we can say that the initial velocity, okay, BOY, V, to subscript na OY is equal to positive, no? Positive 90. Okay. Atong 180 sine of 30 degrees, which is equal to 90. Okay? So, if that is your BOY, then you can write your velocity Y equal to 90 minus 9.81 t. Okay? That's the equation. Okay? And we know also that dy dt is equal to v subscript y, and that is equal to 90 minus 9.51 p. Okay? So, integrating this equation will give you an equation of y equals to 90t minus 9.81 divided by 2t squared plus constant of integration, c. However, at time equals to t, y is equal to, let us say, yo initial, yo is equal to 150. Okay? Equal to 150. So therefore, we have equation of y equals to 150 plus 90t minus 4.905 t squared. T squared. Okay, so this is the equations that I can establish along y direction. So I will paste it. So that's it. This is what the things that I have said a while ago. No. that along y direction, based on the graph, the initial y is 150. Okay, that's 150, and the acceleration, although not given because the projectile is pulling vertically by the action of gravity, it's not given in the problem, but kita na lang yun ang supply is equal to 921. It's equal to the gravitation, but the sign is negative because gravity is directed towards opposite the positive y that we assume here. Because this is the right-hand roll of the xy axis. Okay. And knowing that acceleration is equal to negative 9.81, okay, we know that the differential of the dy against time is ey, and we plug in negative 9.81 and integrate that, we have dy equals to negative 9.81 t plus c. Okay, at time equals to 0, dy is 180 sine of 30 degrees. The vertical component of 180 here, so that's it. 180 times sine of 30 is 90. That's why here I have 90. Okay, and substituting 90 to C, so we have By equals to 90 minus 9.81t. This is my equation for velocity. Velocity with a subscript y. And I know also from my calculus, or from your entire calculus, that the derivative of y with respect to t is equals to v sub y. But v sub y is already established, is equal to 90 minus 9.81t. And then if I'm going to integrate this differential equation, I will have 90 y equals to 90t minus 4.905 t squared plus c. So ang c nagsinamok, but we can get rid of that because at time equals to 0, the projectile is still at height 150. Wa pa siya nilupad, 150. So we substitute that. So my equation for y is 150, 90t, like that, no? Okay, we can solve the time travel of the projectile if we set y equals to 0. So if we set time here, if I will graph the time, okay, first I will graph the time, okay, times seconds, and then I have the y meters. Okay, first I'll assume secant 0, then I will have here plus 3 plus 0.1. So I'll say time increasing, I copy that, then plot it as much as I can, maybe up to 200, up to this. Okay, base. So I have my set of time. Then what equation of y I'm going to use is this one. The last equation, that is plus 150 plus 90 times, I think that's A3 minus 4.905 times A3 times A3 again. Why multiply that by 3 again? Because that is t squared. Ngayon, nahimo mo siya 4.905 because that is over 2. 9.81 divided by 2. So, that's my equation of y. Then, I am going to put that in a box. Put the box. Okay. Then, makita na ni mo din hiya. Tungod ang equation. Numerically lang ni siya, ha? Pero pag solve na niya, solve gini mo quadratic equation, pero kita na to ang value niya, ha? So siyang dapat tapit. Okay. Ano ba kami sa ubos? Wala pa, layo pa kayo. So, ako siyang ipakuhan. Tiyahon din at sa bus kayo. Abot po siguro nito. Ano na. Okay wala na. So, nasa siya sa mga 19.9. 19.9 ang time niya. Abot na siya sa 0. So, we can solve that actually here. By this equation, I will have 4.905 t squared minus 90t minus 150. I can solve that by quadratic equation. I have my calculator here. So, maybe A there is equal to 4.905. B is equals to minus 90. And then, ang C equals to negative 150. The formula is minus B plus minus square root of B squared minus 4AC divided by 2A. Okay? So, I will have an equation 90 plus minus square root of 90 squared is 8100. Then, I will have plus 4 times 4.905 times 150. Divided by 2 times 4.905. I will solve that. Okay. 4.905 times 4 times 150 plus 90 times 90. Then I will take the square root. So 105. Okay. I will use the positive sign. So I have to minus it with 90. Then divide it by 2. Divide it by 4.905. I get the time of 4 times 4.905 times 150 times 100 plus 90 divided by 4 1.85. The time is 9.886. Okay, time that the projectile hit the ground is 19.886400972 seconds. Okay, that's the time. So, analyzing it from the graph, okay, so nasa sa 19, no? 19. So, my calculation here using quadratic is okay. And my graph also, if I'm going to graph this from there to 20 seconds, let's say 19.9 lang, I will insert a graph, that one. So, kita na ko din ang y versus time. Okay. So, from this, at y equals to 20 seconds, at time equals to 10 to 20, almost 20 seconds, it already at 0. So, this is the y versus t. No? Y versus t. Okay, so, the actual value is 9.886 seconds. So, that answers the time for the projectile to hit the ground. Yeah, I answer already 50%. The maximum elevation, of course, will be the horizontal distance, no? The horizontal distance. So the total time is that one, no? Time 9.886. So if you substitute this time to your equation of x here, x which is 180 cosine of 30 degrees t, I will have the h max, no? So this is the time of the projectile in air. After that, it already hit. So you can also determine the x. Okay, the x is the time, this horizontal distance that the projectile traveled at time t. So 180 cosine of 30 degrees. So cosine of 30 degrees is 0.866 times 180 times 19.88 40972. So it's 3,100. 3,100 meters maximum distance. Uh, distance, max distance, max distance that projectile travels. Okay. So, the horizontal distance okay na kayo, no? The greatest elevation above the ground reached by the projectile. So we have an equation of By equals to 90, 9.81. And if By becomes 0, the projectile will not go up anymore because it's 0. What happened here is the projectile has an initial velocity of 90 meters per second. That is the vertical component of 180. And since it is fired with an angle of 30 degrees, the vertical velocity initial is 90 meters per second, being 180 sine of 30. Now that velocity, as time increases, will reduce until that the equation the velocity becomes 0. Okay, so if we are going to determine that, we just set 0 equals to By, and then the time here is equals to 90 positive 90 divided by 9.51. Okay, so that is the time 9.17, no, 9.17. So maximum height, projectile reach maximum height, projectile reach max height. Okay, kung ato na siyang i-graph, okay, manghulam ko din yung kuan. Okay, laman ako ng time na ito 9.17. So na din 9.17. Tama din eh, no? Ako na siyang hulman. Ako na siyang kopyahon, ibutang na ko diha. Yan siya ako sisibukan. Nya, ilirasan ako ng equation sa V, Y, kuha siya, plus 90 minus 9.81 times C3, tumaw na siya, 90. And then ako na siya kopyahon, ako na siya ikuan sa boss. So velocity is actually slowing down. 79, like that. So at 9.1. Okay. So na din ni dapat usok. Nakawit siya og 500. So ang sakto jud nga time actually, kung ato to siyang gamiton is kini, no? Ako na siyang kopyahon, niya ako na siyang i-paste din. Ako na siyang i-paste na values lang. Okay, I have that. Kopyahan ko na siya. Copy. So, paste. So, mo na siya ang velocity niya, no? Niya, kung ako na siyang kopyahon, copy niya, ako ibutang din eh. Ang may tabo niya, paste as values. Okay. So, mo na siya actually ang maximum height that the no? So maximum height. Okay, so max height max y is equals to 562.844 562.844 meters. Okay. So mauna ako pagsog duha man kabo kung tugutan the horizontal distance from the point projectile strikes the ground. So this is the answer, 3,100, and the maximum height is 562. Above the ground siya. Above the ground. So, this is it. Okay. So, class, sa sa inyong kuan, inyong assignment, katuna ganiha katong i-go down nako, no? Ang ikaduha nga assignment nako is ako lang ni siyang usbon, no? Usbon. Okay? Ang angle instead na 30 degrees, imuan ninyong 20 degrees. Okay? 20 degrees. Kunya, ang initial velocity, instead na 180, imuha ninyong 250. Okay, 250. So, luhaga kabuk ang assignment class next meeting. You submit that because that will be credited as your performance, no? So, like, not really like a quiz, but it has some percentage in your grade. So those who cannot submit will have a zero, no? Will have a zero grade. Okay. So that's it, no? So there are two assignments, no? Katong isa katong buhol nga tagag initial velocity pero going down, ha? Going down. Okay? From the height of 20 meters. Ikaduha, this problem is twisted, no? The angle being 45 degrees and the velocity of 250 degrees. So the height is still the same. The unknown are still the same. Okay? Only the velocity and the angle is changed. So are changed. Okay? So
Excel ni sir.
20, sir, 20.
ha?
20 degrees.
20 degrees ba kung gingon primero?
Oh,
45.
Oh,
sir.
sir, 20.
20.
sir.
Sige. Prepare mo gusto sa ka-problem. 20 degrees, kunya 250. Sayo na siya actually kay paluhon nung ninyo, no? So, bisag usaon niyo solve, no? Usaon niyo solve basta kay na I answer. No? That gives you
Sir, sa e-learn
the idea of kinematics, no? Yeah, katong isa, instead na toss siya up, kay pumunto siya atong example, ang new assignment, toss down. The same magyapon, negative 10 meter per second. Okay?
Sir, na may access sa mga files, sir?
Unsa nga file?
Katong PPT o katong imong gibuhat na Excel, sir ba?
Mura mo to siya blackboard, no? Mura to siya blackboard. Actually, mo ta akong blackboard. Gusto din niyo itong kopyahon?
Oo, unta, sir, kay dili kay na uban student sa mo, sir, na kapilit, sir, ba niya? Dili ka catch up sa mga Excel.
Sige, ako lang to siyang i-post, no? So, akong lecture ka. Okay?
Thank you, sir.
Okay, so kato.
Excel file ang pag-send, sir.
Di mo Excel file. Excel file mo, di solution na mo to siya. You can make your presentation a lot better than that. Diba na ipa.
So, 110,
Example,
sir.
presente mo ang graph.
on paper lang, sir.
Oo. Kuha ninyo. Tawag ni soft copy ninyo. Imuba ninyo. PDF lang. PDF.
Picturean lang din, sir.
Oo.
Scan.
I-PDF. I-send na din sa ako. I-send na din sa one. Usually, I will open a page where you can submit. Don't submit it anywhere but on the page na nako, no? So I will post that today, no? Today, but including the assignment. Okay. You will submit that as an assignment, okay? Okay, I will give a deadline. I am going to collect that. Finish our next meeting Saturday again.
Saturday, sir.
Okay, so I am going to post a page where you can submit it with a deadline on before our class starts. Okay? Okay? That will be Saturday 9 o'clock next week.
Sir, once a week ra ka mag-klase, sir. Dili na ka mag-klase sa Wednesday.
Dili na kay ngano conflict mo sa isa ka subject. So una nga gi-state na to ang time karon. Do you have problem with that?
Wala man,
Oo,
sir.
okay ra, okay ra.
Sir.
Okay. Actually, ang chairman sa C department na nag-ingon, no? So, ang atong buhaton, mag-break na lang tag about 10 minutes, about 10:30. Then we go back. Okay?
Sige sir, thank you sir.
Okay lang. So, ang akong i-send, gato, akong i-post karon is ang kuan, ang Excel nga atong solution karon. Ikaduha is, atong asa mo nyo submit ang assignment. Dili lang gyapon sa e-learn. Ayaw mo submit sa akong email kay dili na ko makita tungod sa kadaghan kayo ng mga email, mga bot. So, kung kamo mag-submit tanan, dili lagi na makita tanan, no? Eh, tabunan, daghan kayo, no? Mo gahi akong computer, no? So, kaya matong sa e-learn, kay kamo gid tanan, no? I will give a deadline, usually, before ta mag-start, no? Before ta mag-start sa atong class. So, that will be 9 o'clock Saturday. Okay? So, before I am going to sign out, I will answer 2 questions if there are any or concern. Okay, 10, 9, 8, 7, 6, 5.
Okay ra to encoded, sir ba?
Okay, ikaw lang niyo, PDF lang niyo yung submission, ha?
Sa
So,
email
okay,
ra ka po nimo, sir.
ha?
E-learn, e-learn, e-learn.
E-learn. Submit it. I will open the page as assignment, okay?
Thank you, sir.
Okay, so bye. Thank you for coming. See you.